Prove that the square root of 2 is irrational. This is one of the oldest proofs in mathematics. It was in Euclid's Elements, and it's a beautiful use of the proof by contradiction. As it's a proof by contradiction, we're going to suppose the negation first. So we're going to suppose that root 2 is rational. And if root 2 is rational, that means we can write it as a fraction. And we're going to assume that this is in simplified form, but m and n are both going to be integers, and the highest common factor of m and n is equal to 1. This bit here is telling us that the fraction has been simplified as far as it can, and that's going to be important later on. But we know that that's true for any rational number. We can simplify it. So all this is saying is this is written as a fraction in its most simple form. So from there, we have, since root 2 is equal to m over n, 2 is equal to m over n squared, which is m squared over n squared. Multiply through by n squared, we get 2n squared is equal to m squared. But that means that m squared is even, and that in turn means that m is even. Now, we do have a little bit of a jump there, but if you look back at the previous your turn, we showed something about cubes. You can do something very, very similar with squares by contradiction to show that if m squared is even, then m must be even. If m is even, that means we can write m as 2k for some k, which is an integer. Now we're going to substitute that m back into this here. So that means we have 2n squared is equal to 2k squared. So that means that 2n squared is equal to 4k squared, which means n squared is equal to 2k squared. And that means that n squared is even, which means in turn n is even. And here we've reached a contradiction. In this supposition, where root 2 is rational, both m and n are even. But we assumed that m and n were the simplified fraction, so their highest common factor was 1. If they're both even, then the highest common factor is at least 2. So this is where the contradiction comes in. And so root 2 is irrational.